Every few weeks, there is a new term in the AI world, like prompt engineering, context engineering, loop engineering, and now there is graph engineering. And honestly, my first thought was, is this a real thing? Or is it just something someone invented to make the rest of us feel behind? And you might be thinking the same. Do we really need this many techniques? What was wrong with the previous ones? So let me try to explain each technique and what was wrong with it that led to the next one. Let's start with prompt engineering. In simple terms, it's just writing better instruction. You go from write me a blog post to write me a 600 words blog post for beginners. Keep the tone friendly. That's prompt engineering. And for a lot of the things, it's genuinely all you need. But what's wrong with prompt engineering? See, the issue is that it works completely fine when the task has one step, like writing a blog post. But it starts falling apart when the task has multiple steps that depend on each other, like research this topic, then write a blog post on it, then review the blog, and finally post it. This is just a small example, and I am well aware that the current models are quite capable of handling this kind of task. But you get the idea.
And you have probably faced this yourself where you give 5 instruction and the model only follows 3 instruction. And the annoying part is you can't tell which step went wrong because there were no steps in the process. It's just a blob of work. So the next obvious fix was to give it more context. And so context engineering came into existence. You give it the right material to work with. So instead of just asking for a blog post, you hand over your brand guides, past successful posts, your target audience. Same model, but now it has more context. But what's wrong with this technique? Well, first, more context isn't automatically better. Past a certain point, things start to get lost in the middle. But that's not the real problem. The real problem is this: you improve what it knows and not what it does. Because you gave it the style guide and it still wrote paragraph 4 in the wrong tone. You gave the model set of instruction and it still skipped few of the instruction. So now you got the control over the information, but you still have no control over the decision. So the next thing people tried was making the model check its own work. And that's loop engineering. You tell the model, before you show me anything, read it back. If it's wrong, fix it. Don't come back until it's right. And honestly, this does help. It catches real mistakes. But look at what's actually happening here. The thing checking the work is the same thing that did the work. It's like asking the student who did the homework to be the one who marks it. And here's the other half of it. It's also the one deciding when to stop. So it either quits too early or it runs 15 loops and burns your money on something that was already done in the second loop. So now you can see what you actually need. The checker has to be somebody else, which is exactly what graph engineering does. Now let me give you the technical definition first. So graph engineering is representing an AI system as an explicit map of steps and allowed transition, where control decision, so what runs next, when to retry, when to stop, when a human signs off, all lives within the code, outside the model. Quite a mouthful if you ask me. But in simple terms, you take the decision away from the AI and you put them into process. And the easiest way to actually see this is to forget about AI for a second and think about a restaurant kitchen. Let's take an example of the restaurant kitchen, and when an order comes in, it goes to the station. The order is like grills, salad, fries. The cook makes the dish, but instead of going to the customer, it first goes to the head chef, where he looks at every single plate before it leaves. Wrong plates are sent back, and right plates are sent to the customer. And the ticket travels with the order the whole way, so nobody has to remember what was asked for. Now notice what nobody did here. Nobody wrote, please check the food on a poster and hope for the best. The kitchen is built so that the food physically cannot reach the customer without the head chef's approval. And that's exactly the whole idea. A prompt is a sign that says please don't, and a graph is a wall. Same rule, complete different world. One of them is hope and the other one can't be skipped. So mapping it back, the stations are your steps, and some of them have AI in them, but some of are just normal code, a database lookup or a person clicking approve. Not every step is AI, And that's the part most people get wrong. The approval is your checking step, usually a different model with one job that didn't write the thing it's judging. The ticket is your work getting carried between the step, so no one has to reread the entire conversation every time. And the manager is you, the last step before anything really happens. Now you might be thinking, hold on, this is just a normal process. And honestly, yeah, half of it is. Assembly lines works like this, expense approval works like this, hospitals work like this. This is not something we have invented in 2026. But here is the part that actually new. In normal process, a steps either works or it breaks, and you can tell which one happened. With AI, a step can finish perfectly and still be completely wrong. It looks exactly like the version that's right. That's why this system need a checking step in a way older processes never did. And here is the funny part. You have probably already used graph engineering without realizing. When you ask Claude to do a deep research, it's not a single agent doing the job. A lead agent plans out the work, then spawns a bunch of smaller agents that goes out and do the research in parallel, each with its own separate memory. And then a complete separate pass goes back and check the citation. So that's not a chat, that's a kitchen, a station, a chef, and a ticket. But graphs are not without their drawback. Anthropic has published their own numbers on this. Their multi-agent research system used about 15 times more token than a normal chat. One research session can run into millions of tokens, but the output was around 90% better than a single agent on the same task. So you would think, fair enough, you pay more, you get more. And let me actually show you what that cost. A single deep research run in Claude can spin up to hundreds of agents, and every single one of them starts by reading the same big block of instruction. Add that up and you have already spent millions of tokens before any real work has been done. That's roughly around $10 for Claude Opus 5 for just a single question. Except the real number is closer to $1, and that's because of something called prompt caching. So back to our kitchen example. Let's say 100 order comes in, all for the same dish. Every cook works on it and every cook needs the same recipe. Now you could hand each of them their own printed copy of the recipe. That's 100 printouts. Or you can pin one copy on the wall and they all read from that. Same information but just one printout instead of 100. That's all caching is. The instruction gets stored once and every agent after that reads the stored copy for about a tenth of a price, which is how your $10 turns into a $1. But the recipe has to be on the wall before anyone looks at it. If all the 100 cooks walks in at the same time and nobody has pinned up the recipe, they all start printing their own recipe. Same goes with the agent. The cache only exists after the first one gets an answer back. So if you fire all 100 of agents at once, they can all miss it and you are back to paying full price. Which is awkward because running everything at the same time is the whole reason you built a graph in the first place. And there is one more line in the write-up which is very easy to miss. They found out that the token usage alone explains about 80% of the improvement. And separately, there is a research showing that if you give a single agent the same token budget, it catches up. So when you put those two things side by side, it gets a bit uncomfortable. Because a lot of what looks like multi-agent is smarter might actually just be multi-agent is allowed to think 15 times longer. Now that doesn't make the graph useless. Running things at the same time is genuinely faster, and giving each step its own memory genuinely keeps it focused. But the graph isn't doing any magic. You are paying for that better answer in tokens, and you should know that before you build one. So why now? So why is everyone suddenly talking about graph engineering? If this is really just a process and checking, so why is everybody talking about it now? Because people tried this back in 2023. Microsoft had agents talking to each other. LangChain was building the same exact thing, and it basically went nowhere. But what changed? It isn't the graph, it's what one box can do now. Back then, a box was a single AI call. Today, a box is full of agents. It has tools, it can run commands, read files, browse the web. The boxes finally got good enough that connecting them becomes an interesting problem. So what do you actually do with this? Especially if you don't write code. Honestly, you can already do it. Tools like N10 or Zapier or Make.com that canvas of box and arrows, that is a graph. You have been doing graph engineering this whole time, you just didn't have the word for it. And wherever you build it, three things carry over. First, the checker can't be the doer, it has to be a separate entity with its own job. Second, you set the limit, not the model. 2 retries, then it comes to you. And third, put a human in front of anything you can't undo: sending, publishing, paying, etc. And the honest last word is, you don't need a complete recipe to make a sandwich. If your task is one step, low risk, and you notice straight away when it went wrong, just ask the AI. Most tasks are like that. Building a whole process around them costs you more than it gives you. To summarize the whole video in a single line, so I would say prompt engineering is what you say, context engineering is what it sees, and graph engineering is what it is allowed to do.